Hey, welcome. We're always on our phones, right? But how do they actually work? I mean, before we can even think about diving into the crazy security of 5G or even 6G, we've got to get a handle on the basic architecture that makes it all tick. So let's start right there at the beginning.
Really think about it for a second. You tap out a message, hit send, and boom, it's on your friend's phone halfway across the world. How in the world does that happen? It feels like straight up magic, doesn't it? But behind the scenes, it's this incredibly complex and super secure process.
Okay, so the first thing you've got to realize is that your phone isn't just having a simple chat with that cell tower you see down the street. Nope. That tower, that's just the very first stop on a much, much longer journey for your data. And that is the hidden world we're about to explore together. It's this whole other universe, this massive infrastructure that was literally built with security baked in from day one. So let's break it down piece by piece. So to really get a grip on how this all works, we can pretty much break the whole mobile network down to three main pillars. You've got your device, you've got the cell tower, and then you have the brain of the whole operation, the core network. Let's take a look at each of these one by one. All right, first up, we've got what the industry calls user equipment, or just UE for short. Now, this is just a fancy term for your phone, your tablet, maybe your smartwatch, basically anything with a SIM card. And that little SIM card is what gives your device its unique identity on the network, making it the very first link in the entire security chain. You know, that tiny little SIM card is so much more than just a piece of plastic and silicon. It holds two absolutely critical pieces of information. First, your International Mobile Subscriber Identity, or IMSI. That's a unique number that identifies you on any network, anywhere in the world. And second, and this is the big one, a secret authentication key. This key is a cryptographic secret that's shared only with your network provider. It's pretty much the foundation of your entire digital life. Okay, next up is the part of the network you can actually see the base station, or, the cell tower. This is the antenna that your phone is talking to wirelessly. Now, you might hear some nerds call it an E-node B if you're on a 4G network, or a G-node B for 5G, but its job is exactly the same. It's managing that radio connection to your device. And this is a really great way to think about what it does. The base station isn't just a simple antenna. It's a secure bridge. It's what connects the Wild West of the public airwaves to the super private, super protected core network. And that brings us perfectly to our third and final pillar, the core network. Think of this as the brain of the entire system. It's this complex web of servers and routers that does all the heavy lifting. It authenticates you, it routes your data to the right place, and it enforces all the security rules. Okay, so now that we've got the three main parts down, the device, the tower, and the core, we can start to look at how information actually moves between them. And it turns out not all data is created equal. There's this fundamental split in how traffic gets handled. And you know what? Understanding this split is absolutely key to understanding mobile security. Think of it like air travel, okay? Over on the left, you've got the control plane. This is like the air traffic control system. It's not carrying the passengers. It's handling all the signaling, the authentication, the coordination, all the background stuff that makes sure your flight or your connection is set up correctly and safely. Then, over on the right, you have the user plane. This is the airplane itself. It's what's carrying the passengers, which is your actual data, like your video stream or the website you're looking at. And because they do such different jobs, they need completely different kinds of security. All right, so we've got the architecture, we've got the two lanes of traffic, but what does this all look like in the real world? Let's actually walk through what happens the moment you turn on your phone, that initial digital handshake that sets up a totally secure connection to the network. Now, here is the most vital, the most important principle you need to get about mobile networks. They are built with a security-first architecture. I mean it. Before a single byte of your data even thinks about hitting the internet, before you can do anything, the network's number one job is to prove you are who you say you are. Security isn't tacked on at the end. It is the front door you have to walk through. So let's trace this journey right here on the slide, step by step. First, you power on your phone, and it starts sniffing around for nearby base stations. Then it picks a network it wants to join and sends over its identity info. Now, here's the magic part. Step 4. The network challenges the device to prove it's legit. And only after that proof is accepted does the system securely cook up some temporary session keys. And finally, with those keys in place, and only then, can encrypted communication actually start. It's this precise, security-obsessed dance. Every single time. So, how exactly does the network challenge your phone? And how in the world are these keys made? Well, this whole process relies on a really powerful set of mathematical tools. So, let's crack open the cryptographic toolkit that makes all of this security actually work.
So, the main mechanism here is called challenge response. It's actually pretty clever. The network sends your phone a random one-time challenge. You can think of it like a super complex, unique math problem. Your SIM card, using that secret key we talked about earlier, calculates the one and only correct answer and sends it back. And here's the genius part, the thing that makes it so secure. The secret key itself is never sent over the air. It never ever leaves your SIM card. It's only used to prove you have it. And this cryptography stuff isn't just for that one-time handshake. Oh no, it is woven into the very fabric of the network. We see it in authentication, which we just covered. It's used for key derivation. That's the fancy term for creating those session keys. It provides the encryption for all of your personal data and what's called integrity protection for all those control signals to make sure they're not tampered with. It is quite literally everywhere. So why go to all this cryptographic trouble? I mean, really, what's the big deal? Well, it's because mobile networks aren't just for making phone calls anymore, right? They've become the critical infrastructure for our entire society. For our banking, our healthcare, our logistics systems, our modern world just runs on this technology. And without all this layered security, the risks are, well, they're huge. Attackers could set up fake base stations, sometimes called stingrays, to trick your phone into connecting to them and then steal your data. They could use IMSI catchers just to track your physical location. They could eavesdrop on unencrypted calls or launch these crazy signaling attacks that could knock out service for an entire city. And these aren't just some sci-fi theories. These are the very real threats this whole architecture is built to defeat. And this security has been constantly changing, constantly evolving. You know, the early 2G networks, while they were revolutionary at the time, had some pretty major security flaws that were, later exploited. Then 3G came along and massively improved the authentication process. 4G brought in much stronger encryption and better ways of handling the keys. Now with 5G, the big focus has shifted to privacy, with new features designed to encrypt your IMSI, that permanent identity we talked about, making it way harder to track you. And if you look ahead to 6G, well, the industry is already planning for a future of zero-trust architecture and even post-quantum cryptography to defend against threats that don't even exist yet. Each generation learns from the last and just gets stronger. So look, if you take away just one single thing from all this, let it be this. A mobile network is so much more than just a radio system. It's a massive, global cryptographic infrastructure. It's designed from the ground up to manage trust and security for literally billions of people. Which leaves us with one final and pretty crucial question. We've built this incredible security foundation that has evolved over decades. But as we connect everything, our self-driving cars, our medical devices, our smart cities, to these networks, the number of ways things can go wrong just grows exponentially. So can this architecture keep evolving fast enough to secure a future where literally everything is connected? That, right there, is the challenge for the next generation of mobile tech.